Today I'm speaking to Shanon Jackson, software engineering chapter lead at Qrious, who's joining us from Auckland, New Zealand. Shanon has been using Typescript for over 6 years in production, and his recent work revolves around production use cases for the Typescript compiler itself. In his spare time, Shanon can be found working on his side hustle Flack, a peer-to-peer rental platform, and he also enjoys hiking the many tracks in his home country of New Zealand. So Shanon, it's great to have you here.
Great to be here.
So let's get right in. You've been using Prisma and you've come up with some interesting use cases, especially to bring sort of end-to-end type safety from your database all the way to the front end. And today we're going to dive into that. But before we get into that, I'm curious to hear, how do you use Prisma these days?
So we kind of use it across everything. We have around 10 projects we run, and we use it pretty much everywhere as our main form of database access. Sadly, before Prisma 2 came along, we had to use other libraries to kind of perform that ORM functionality. These were libraries like TypeORM and a few others we kind of experimented with but didn't have much success with in the long term. One of the main reasons we use it is obviously for the end-to-end type safety it really provides, or all that we've managed to achieve with it.
Mm-hmm. So you were using TypeORM before this. Were you using any other sort of database access libraries or ORMs?
Yeah, we had experimented with Next. I hope I'm pronouncing that right, or Knex. I don't know how you pronounce it, but it's just the...
Next, Knaex.
Yeah, we did have some very custom query needs where that library was just a better solution for us because the query building aspect of it just was better for the use cases we were using. We've done a lot of work with Next as well. But other than that, just TypeORM.
And at this point, would you say that Prisma sort of fulfills all of your querying needs when it comes to interacting with relational databases?
Yeah, absolutely. The ease of use of it, the fluid API was definitely some of the main attractors for us. We kind of try to follow a functional programming paradigm. So we really liked that we could get away from these like DAOs, they're called, or data access object-esque libraries like TypeORM. But there's a whole bunch of them out there for other backend languages as well, where it's more OOP, like you have classes behind the scenes. You've got to maintain those class definitions, and it just feels very clunky. So we really like the aspect of Prisma where we feel like we can be following a more functional programming paradigm.
This is actually the first time I hear the term OOP, but I gather that you mean by that object-oriented programming style.
Yeah, that's the one. Yeah.
So what would you say is the main value that you get out of Prisma? You mentioned end-to-end type safety, but I'm curious to hear sort of the full picture.
Yeah, so the main value we get out of Prisma is obviously the ORM capability it has. So it's really just mapping that model into JSON. And then because that mapping exists, we can essentially use the same models or model definitions up and down the pipeline and the request and responses. So it really helps. I don't know if you've ever seen APIs before where they might have something like a user object and they might be like changing the fields throughout that pipeline up and down. And so I really like that Prisma as an ORM provides us both the mapping of that from the row into that JSON object, but also the types behind the scenes as well.
Yeah, and I'd like to pause there because I think one of the biggest differences sort of with Prisma when compared to other ORMs is that while other ORMs map database tables to model classes in your programming language, what Prisma does really is it maps queries to structural types in TypeScript. And I think we'll get a look at that because really the structural typing system of TypeScript really provides a lot of flexibility, especially in cases when, as you mentioned, you're going down the pipeline. So, for example, from your backend, you might want to conceal some fields for the front end. And so you really have this flexibility to sort of use the generated types that Prisma generates for you and to sort of like really control what goes down the stack to the front end.
Yeah.
And so I'm curious to hear, did you have anything to share?
Continue on.
So how does collaboration look like with multiple engineers working on your projects? I imagine that you're collaborating. You mentioned that you have multiple projects, and I imagine that you also have multiple teams working on this.
Yeah, so we have multiple projects, around 15 now, but only around 4 to 5 that we actively maintain on an ongoing basis. In terms of what collaboration actually looks like, these projects normally have maybe 3 to 4 developers on them, so that's quite a small team, probably in most respects, but they're a team of like 3 to 4 senior developers, so we're able to go quite quickly. Our kind of collaboration workflow is that we normally follow like a Git flow-esque workflow. So, PRs, dev, staging, production branches, produce an artifact on the branch, that kind of thing. However, more recently, we're starting to move towards like a more trunk-based development approach. And it's a slow process to get there, but all the developers on our team really see the benefits of like modern trunk-based development, and so we're hopefully going to start the road to, or the journey to get there.
And when you speak about modern trunk-based development, do you mean where you have like a main branch and then every feature is sort of developed on an individual a feature branch for it, and you have a pull request and you sort of keep that branch updated from your main branch?
Yeah, so I'm still learning on the trunk-based terminology, but yeah, trunk-based, you can have feature branches with it. I think there's like a kind of like a spin-off paradigm on trunk-based development where you can have feature branches, but the main kind of principles behind it is that you're just continuously integrating your software into the master or main branch. And you have to have the right controls in place to allow you to do that safely, because some people might be grimacing in the crowd, but you need to have an automated testing framework in place. You need to have the property QA policies in place. And just because you're merging into the master branch doesn't necessarily mean that every commit into that branch is deployed. That's continuous deployment, which is just slightly different. It just means that you're always pushing working software. So you're never pushing a commit into master branch that isn't working software. And then, whatever deployment cycle you want to follow after that is really up to your team.
Right, and I guess you rely heavily on like automated CI tooling to make sure that you're confident about what's in your main branch.
Yeah, absolutely.
And so speaking about that confidence, what role does type safety have? I mean, you've been using TypeScript for 6 years now, so you've been in the TypeScript world for quite a while. How has that sort of transition been from JavaScript to TypeScript? And what are the implications sort of type safety when working with the database?
Yeah, so TypeScript is pretty much critical, really, to everything we do. Just the assurances it gives you around what it means when your build passes are amazing to have in place, especially when you are doing your application development in something like Next.js, where you have a full stack TypeScript application, and the guarantees TypeScript gives you across your front end and back end as well are really, really powerful when they're properly in place. To go a little bit deeper, we really try and basically go after type safety as like a number one priority. So it means really steering clear of any innies or anything like that. And in the pursuit of that, we really just learn to trust the compiler. So when the program compiles, it generally means that it's working. Well, once the tests run as well. However, that sometimes isn't always possible. So in the patches where you need to have greater levels of guarantees, that's when testing starts to come into play. And so if we weren't using TypeScript, what that would mean probably in practice is that we just have way more tests that are just covering the stuff TypeScript would cover for us. So there'd be tests that guarantee the API contracts and tests that guarantee that a function isn't passed, an incorrect parameter or anything like that. And so it really just allows us to, it gives us the guarantees, but it also allows us to not have to write as many tests.
Yeah, and I always like to stress this point that, the guarantees that you get from the TypeScript compiler, they are guarantees that you would otherwise have to test at runtime. And the challenge, obviously, with runtime is that you now have to start running software and actually test it running, whereas the TypeScript compiler is sort of giving you a much tighter feedback loop that you can sort of be assured about many things. And I guess the biggest benefit, especially for me in sort of most of my experience working with TypeScript and Prisma, is really that it reduces the number of tests that I have to write, and that's always fun.
Yeah, and that's another one of the reasons why I like Prisma as well, because a few of the other ORMs we've kind of used in the past, say like Mongoose, they've kind of like broken exactly what you just said there, like this kind of idiomatic TypeScript where they're trying to achieve like that safety with runtime types. So in Mongoose, you have these like data models where you're essentially just implementing runtime types, or some kind of like runtime model. And so I find that TypeScript engineers or TypeScript developers generally, or at least in our team, find it quite painful, or they feel like it's wrong to work with these models. And I feel like that's just because these models aren't idiomatic TypeScript, because TypeScript isn't about runtime type safety. And so, if you're starting to use these libraries that have a heavy focus on this runtime type model, I think your team, not all the time, but your team might want to question why you're using TypeScript in the first place, because it might not be the best fit, because other backend languages just give you runtime types, so you might just want to use one of those.
So you really touched on something important here about sort of runtime types, and that sort of brings us closer to validation, and especially in the context of sort of you're building APIs too. And we're going to get a bit more into the technology stack that you use today and into the details of that. But I'm curious to hear, before we get into that, how do you sort of relate validation, runtime validation, and types? Because while types can give you a tight feedback loop, they can't sort of guarantee things like API input, which is a runtime thing. So how do you think about validation in your TypeScript apps?
Yeah, so this might trigger some alarm bells for a lot of people, but this is just my personal opinions on it. And that is that if you have internal APIs, really try and avoid doing as much validation as possible. So just allow it to, if anyone wants to manipulate that and corrupt their own data, just allow them to. Obviously, you have the proper security boundaries in place. So just allow it to basically throw a 500 if anyone passes anything they shouldn't be for your internal APIs. For external APIs that you're exposing to other people, you absolutely should have a lot of runtime type safety in there. Normally, the way we like to do that is using some kind of runtime or like validation library like Yup. So Yup's really popular with our team. We're not too much of a fan of the API it provides, but it gets the job done. It's quite popular, so we've never really had much problems using it. So we generally just use that on our external APIs.
And what was the name of this library that you mentioned? Yup?
Yup, yeah. It's YUP.
YUP.
Yep.
Okay, and essentially there, do you end up in a situation where you're sort of duplicating a lot of the types that you have maybe in your Prisma schema for validation, of course, with more granularity, like you can check, for example, for an email, something that you can't do with the TypeScript compiler?
Yeah, absolutely. Yeah, you're pretty much spot on there. So yeah, it's pretty much, it is a little bit of double declaration, double declaration problem where you might have a user you're creating in Prisma. That user has a name field, and then you've got to implement a Yup schema that kind of mirrors that a little bit. And it's sad that it has to be like that. But again, we kind of just only follow this if it's external APIs, and most of our projects don't normally expose many external APIs.
I see. And so let's get into the tech stack that you're using today. I'd love to hear more about which databases you're using, what API technology. I know that you're using a lot of Next.js. And also, how do you deploy it? Like, what kind of runtime do you use? Do you take the serverless approach, the serverful approach? Let's get into that.
Yeah, cool. So shall I talk about the web framework first, and we'll go from there?
Yeah, whatever you feel like.
Yeah, so we'll start with Next.js then. So, yeah, we've been using Next.js now for, I think, almost 2 years, or coming up to 2 years. Whenever 9.0 was released, that's probably when we got started with it, just after they'd done the first 9.0 release. I had to play around with it, and I was really impressed with just the front end aspect of it. We had some large React projects where we'd been doing a lot of tree shaking stuff ourselves and code splitting ourselves. And it gets very messy very quickly. This is even before React Lazy existed, and it was getting very messy. And so immediately there was a huge value add for there, just to have the routes structured the way they are in Next, and in a way that are statically analyzable. And therefore, because it's statically analyzable, Next.js can just code split at the route level for you. So this was already one of the main selling points for us on Next. And then that evolved over the 2 years, and to where I would consider Next.js now to basically be like the best-in-class React framework for doing just front-end development. So better than CRA and a few of the other, I guess, React boilerplates you can get out there, or even one you could roll yourself. You're pretty much never ever going to get close to the kind of quality that Next.js provides and developer experience. So that's why we've kind of rallied around Next. So we definitely consider it to be best in class for React. On the back-end side of things, we also consider it to be best in class on the serverless developer experience side of things. So over the course of, I guess, like 2 or 3 years now, we've built up a large amount of maturity with serverless as a technology, to the point where all our projects now basically run fully serverlessly, serverless first, pretty much always where possible. And in that time, we've kind of played around with a few of the other options out there for developing serverless applications, like Serverless Framework, probably know of that one, and a few others. And they really don't come close. Well, they've got lots of problems, but they really just don't come close to what Next.js provides in terms of its experience in creating serverless functions. So these are things like generally Serverless Framework isn't cloud agnostic. So you're essentially coupling yourself to that cloud for life, because all your function signatures, if you're using Azure, you'll have like a context object or something, and all your function signatures will rely on that context object. And it's a similar story in AWS. It's the same thing. And so I really like that the Next.js serverless API structure doesn't have any awareness of what cloud you're using. That has certain implications for how you build your application, because you need to make sure you're building your application in a way that can actually be hosted on that cloud. But so we already like that side of it, but we also like that when developers get into their day, they can just run one command, next run dev, runs their backend, runs their front end on the same port. They don't have to worry about anything like cores or anything like that, and they can actually debug like fully cross-stack. And then obviously you have the TypeScript types, and then all sorts of other things as well that we love about Next, like obviously it gives you like Babel and Webpack, so you can use the latest and greatest JavaScript features that might not be in the latest stable version of Node, and yeah, all sorts of other things.
Okay, so we spoke so far about front end. You're also using serverless. Which cloud platform are you running most of your apps on? Are you using Vercel for this?
Yeah, so I use Vercel in my personal life quite a lot for a lot of my personal projects. So Flack, our peer-to-peer rental platform, is hosted there. Huge fan of Vercel, huge fan of everything they do. Just like the same way I'm a huge fan of Prisma. I love that you guys sponsor all the conferences, propelling the Jamstack community forwards. Really getting out there in the community and doing all this wonderful work. Sadly, in my professional life, there is a lot of fear around Vercel, simply because it doesn't have the brand recognition or company recognition that the likes of AWS or Azure have. And then on top of that, our Qrious as an organization is actually part of Spark, which is like the biggest telco here in New Zealand. And they've got relationships with AWS and Microsoft that they need to maintain. So there's a preference for us to host our stuff there because of those reasons. And then there's all sorts of other stuff like security. So Vercel doesn't have any support for anything like VPC peering, which is like a database best practice for security. That kind of rules it out.
Let's pause right there for a moment in case our viewers aren't familiar with this idea of VPC peering. So first of all, VPC. Do you want to give that a bit of
run through
an explanation?
Yeah, so it's the acronym is Virtual Private Cloud. In Azure, the term would be VNet, I think, is the Azure equivalent. And it's really about blocking your database off from the public internet. And so if you're hosting your functions on Vercel, they won't be able to connect to your database if it's locked away, basically, in offline, basically. And so the way people can circumvent this is there's something called VPC or VNet peering, where another AWS tenancy, I think, can connect to your virtual private cloud if you give them the correct access. But Vercel doesn't offer that quite yet. It is, I think, on their roadmap somewhere. But I have heard they offer it under enterprise tier, but not to your average Joe Blow customer.
Right, and so we spoke about the front end, the runtime. What kind of API technology are you using? Are you using GraphQL? Are you using REST? Or are you doing like a lot of server-side rendering and hydrating your components with, get server-side props kind of thing?
Yeah, so we've used a lot of REST at Qrious. We have started delving into GraphQL. Flack's fully built in GraphQL now. I've been using it for like the last year and a half. My opinions on GraphQL as a technology is that it makes the quality of life for your API consumer really, really good. Like if you're an API consumer consuming GraphQL APIs, man, your quality of life is just phenomenally good. But unfortunately for the API implementer, their quality of life is awful. And sadly, I don't think the maturity of the back-end side of things in GraphQL and Node is quite there yet. I know there's tools like Apollo and Apollo Server and all those kind of Apollo Micro and stuff for serverless, and the Prisma plugin for Nexus and Nexus. I don't think those libraries are quite there yet, and that you should be quite relying on them yet. And I think Nexus has been the prime example of that because they've scrapped their whole plugin architecture. I think they're starting fresh, which I think is a good thing. But I think it's a sign that they're not quite ready yet for mainstream adoption. But I do think they're on the right track. So because of those reasons, we are still predominantly building our APIs around REST. However, other tools out there are trying to remove that GraphQL implementation constraint from you. And so these are tools like Hasura. I can see you nodding there. These are tools like Hasura and I think on AWS it's called Amplify with DynamoDB, and I think they're adding support for Postgres now. And Hasura is an amazing tool, and I've used it for a year now. I use it on Flack. I recommend it to anyone. I've tried to push it into Qrious, but there's been some resistance. Yeah, super keen on it as a technology, and I think that GraphQL will eventually become the de facto standard in the future.
Right. And so what databases do you use?
So for databases, we have like our base architecture. This is like Next.js, React, and Typescript, obviously, that we use in everywhere. And then after that's in place, we kind of start layering other technologies on top, and it really just depends on what the domain problem is. So, use the best tool for the job is probably the best phrase here. So we have a preference for Postgres, but if you know all your data access patterns and all that stuff, there may be a better database for you. So we've got some stuff in Mongo. We were really happy with their kind of near-Sophia GIS stuff. And we've got some stuff in SQL Server.
This is the geospatial kind of querying capabilities that in Postgres would be done with something like PostGIS.
Yeah, that's the one.
How would the two compare in your experience? I'm curious.
Yeah, so they're really similar actually. So, but I have heard PostGIS is faster. I looked at some performance benchmarks online, but I don't know how true that is anymore. If that was ever true, but I trusted them and took them for face value. But yeah, I'd say they're just very similar. They both get the job done.
And so I'll give a quick run through for our viewers in case they're not familiar. So these are basically tools that allow you to use your database to store like geographical locations. And so if you're building location-based apps, like, you're doing a peer-to-peer rental platform and you probably want to show properties on a map, and using these tools like PostGIS and the spatial queries in MongoDB, essentially you're able to take the user's location and then search the database for, say, properties that are within, say, a radius of that location where you're at.
Yeah.
So cool. That's really interesting to hear. And so you're using, in some situations, Postgres, in some situations, MongoDB. Anything else?
Yeah. So SQL Server. On another project that wanted to be Microsoft everything. We're using CosmoDB on an IoT platform. That's going all right, but the CosmoDB bills are quite large. We, in other parts of our business, so not in our team, in other parts of our business, we've got a lot of stuff in Snowflake, Cloudera, and AWS Redshift. So that's more of the big data side of Qrious.
Right. Great. And so for which projects are you using Prisma with? Are you using it for Postgres mostly, SQL Server?
Yeah, so we're using it for the SQL Server project and all the Postgres projects. And they're going amazingly well. And
are these projects also that you started as a greenfield project with Prisma, or are these projects that you sort of retrofitted Prisma into?
Yeah, so almost all of them are projects that have been greenfield, bar one. These are only the projects we have Prisma on. All of them in greenfield, but one. The one that isn't is a mainly GIS project, and that's the one that contains TypeRM. And the Prisma support for PostgreSQL wasn't quite there yet, so we still have some reliance on some TypeORM stuff, but generally it's all mostly been converted to Prisma now.
Okay, very interesting to hear. And so tell me a bit more about what Qrious does. I mean, I'm curious to hear you mentioned that you have about 3-4 developers working on each project, but how are the teams structured, and like, are engineers specialized in like front-end, back-end, and sort of DevOps and infrastructure, or do engineers, you mentioned that they're quite senior, are they sort of jacks of all trades? Because you seem to be like one of those.
Yeah, jacks of all trades. Yeah, so we have built our team the same way that I run. So I prefer to work across the whole stack. I really think that helps you solve problems in very intuitive ways, because you can see what the solution would look like, or think about what the solution would look like completely end to end if you know how you're going to be implementing that on the front end. So it can help you make decisions like, should I implement this logic on the front end? Should I implement it on the back end? All this stuff. And then also you're not blocked as often if you're working full stack. So yes, I encourage all our engineers to be full stack as possible. 1 or 2 of them just work on the front end of another project that has the back end in C#, sadly. So 2 of them just do front end, but all the rest of them are completely full stack. They don't really have a specialty, although I would say most of them are coming from a front end background. So I'd say their database skills aren't as good as they probably should be. But yes, they're coming from a front end background. And we've had a lot of success with this.
And do you think
Oh, you go.
I'm just curious, how do you think that Prisma sort of like makes it for them to start working with the database?
Yeah, Prisma has been amazing because it kind of abstracts away the complexities of SQL, like in the sense that if you're a predominantly front-end developer and you're starting with databases and starting to learn them, the first thing you're going to need to learn is basically the whole SQL dialect. And so I really like that Prisma, like as an abstraction, is more it's more fluid for people coming from a TypeScript kind of background. Like they just have an object and they just access properties on it like they would an object. And under the hood, it's abstracting away that SQL for you, which obviously still has to occur, but it's completely taking care of it for you.
Mm-hmm. And I cut you off there. I apologize about that, but you were sort of going about something.
So I was just going to say that generally it was just one last thing to say, which is generally in my experience, kind of working with people in our team, is that if we're taking an engineer who can write senior quality front-end TypeScript front-end code, they can generally write senior quality TypeScript back-end code as well. So that's just something we've found. But our engineers don't do a lot of testing. We have dedicated QA for that who are quite good. But it's something we're starting to get more into now.
I see. And in the beginning, we touched on end-to-end type safety and how important it is for you. And you came up with quite a nifty trick for sort of ensuring this end-to-end type safety. Do you want to get into that now and sort of show us how this works?
Yeah, so this is the kind of setup we run across all our projects now. It's something we kind of came up with after some experimentation. You can see my screen, right?
Yeah.
Yeah, cool.
So we are looking now at essentially an API route in a Next.js project.
Yeah, so I'll cover the basics as well for those who aren't familiar with Next, just as I go. But so this is a standard de facto Next.js endpoint. They use kind of like file system routing, if you're familiar with something like PHP, where any file in this API folder becomes an endpoint. It just looks for the default export within the file and turns that into the endpoint. The signature for one looks like this. It takes a request response, very similar to Express, with the same methods that is normally within Express. So res.send would send status code 200 and whatever JSON data came from this. So one of the problems we've kind of found with this style of functions is that a lot of important information is just kind of lost. So just as an example, send here is a function that takes a body and returns a void. So therefore the signature of this function would be something that takes a request and response and returns a void, even though we're sending users. And so this isn't very useful information for people who would want to consume this at a type level. So as we kind of thought about this problem more, we came up with some way to kind of get around this without doing anything crazy like runtime types or anything like that. It's just purely idiomatic TypeScript, doesn't involve any library at all. However, it does involve slightly deceiving TypeScript, slightly. And so I'm sorry for the TypeScript purists who may be listening, but unfortunately we're going to break a golden rule of TypeScript and use the anytype in the way we kind of get around this problem. So this is the user's endpoint here. So this is just the one that uses the standard default Next.js style endpoint. And we're going to create a kind of utility function that allows us to transform this into something like this, where we're hopefully this will just come from Prisma and it will all be inferred the whole way up and down the chain. And once our signature looks like this, we'll be able to consume that on the front end. So we'll actually be able to bring that signature all the way into the front end. So I'll show you what that looks like in practice. So I have created this utility here, and I hope people can follow along, but if they can't, I'll publish a GitHub link that people can read through the code. And so I'm sorry for people who aren't familiar with TypeScript if this looks a little bit scary, but I'll hopefully step through it and explain it step by step, because this signature is a little bit beefy. But I would say generally our developers never see this. I think the equivalent file of this within our projects might have been edited like twice in like 1,000 commits. It just sits in the background.
And before we get into the details of this, basically this is something that you define once, and it gives you sort of the flexibility to enjoy having these types for API calls in your front end, in your like front end pages in your Next.js app. And so you define this once, and essentially we're going to get to see how it's used in practice, right? But the idea is we make an API call and we want to know the return type in our front-end code.
Yeah, spot on. Yeah, that's the general idea behind it. So this is just a utility type that kind of helps facilitate that. So for those who aren't familiar with generics in TypeScript, these are basically like variables for types, and they allow you to reference that same type across a signature. So body, query, and the return type here, which is going to come into play soon, are all type variables. Let's just call them that. So we have a signature here that takes f, which is a function, takes a request and response, returns some promise of data. And these will come into play soon. I'll touch on them later. And then it returns basically the standard signature that we just saw before, except what you would probably be expecting is void here, which would be the signature of a Next.js standard function. But we're going to mold that a bit, and we're going to add body and query in here, so we have these available at type level, and we're also going to change the return type here to basically just take that return type of f and basically just return it. In fact, just consider this promise of r for now. We'll come back to these, but just consider this Next.js function that returns whatever f returned. So it's like a wrapping function. It's like middleware, same signature as most middleware functions. And then in the implementation, it's very small. I've shrunk this one down a lot, but there's a lot of stuff you'll want to put in here if you're implementing this yourself, like handling for this stuff. But I've shrunk it down.
Right, these are basically all the error states that you might get from an API.
Yeah, absolutely right. Unfortunately, you're going to see me breaking the golden rules of TypeScript a few times here. That's simply because I don't really care that the function type, even though it returns void, I'm going to lie to TypeScript and tell the TypeScript that it returns users. And I don't really care that I'm doing that because I'm not the one calling this function like Next.js is internally. They don't care if this function is type safe or not. So we're not losing any type safety really because we're not calling this function Next.js is. But
is this, by the way, a function that you would call from the front end?
No, so this is just a wrapper or a middleware. So we'll go to the usage in a second, but yeah, for now you can just think of this as like a middleware. It takes a Next.js signature, and it wraps it and it runs that signature, gets the response on it, which will be say your users, and then it runs res.send for you and sends the users here.
Okay.
Yeah, so this would be I know the signature can get confusing. I get confused when I read it as well because it's like partial application, I think is the word or something. But yeah, so we're just wrapping our function this is wrapping our Next.js signature here, passing.
Basically, you're relying on F as the original sort of API route, and you're wrapping that, and you're relying on F being sort of in a closure created for you that you can access, so that you can do the extra stuff that you need to do there with the types, and then also still call, obviously, the API route function.
Yeah, spot on. And a lot of people who run Next.js projects will probably already have something similar to this in their project. They might have one for doing validating user requests, so they can get their serialize their user from the JWT here, for example, or something like that. So you'll already have maybe something like this if you're running Next.js in your project. So one of the advantages of this is that now with this kind of lying, we can come to an endpoint like posts, and we can take that signature that we had before. So that is this one here.
The standard sort of request response API route of Next.js.
Yeah, and we can wrap it.
And you're wrapping the function with insecure, which is what we just looked at.
Yeah, and it'll type rec and res for you. It gives you the Prisma client, so rec.client is just mutated onto the request object for you. So you don't have to initialize a database connection. It's just completely handled for you. And your body and query now come through here. You can still access them like this if you want to, but the typed equivalent comes through here, and you can type these. So I can say my body is something that takes an ID of a number, and we'll touch on this soon as well. And my query, say, takes a skip of the string, just like standard pagination. And we'll come back to these. So, and then you just return your data, so your JSON, and then this JSON obviously gets run back here, so then that JSON will be returned here, and then it just gets sent. Except the advantage of having this kind of wrapping function now is that if we look at its signature, just this function, the actual export default, so we'll go F something, and we will sin a little bit, and we'll go something like this. And look at what the return type is, and you'll see it's a promise of a post array.
Okay.
And so now we have...
So basically, it's able to use the type system to pick up on the return type of the find many call to Prisma client, and then return that through.
Yeah, exactly, spot on. So now we have the signature we were after, which is that we've removed that void that we had before, that void problem. We've replaced it with the actual type of the JSON that's returning. And even if we have something like hello world here, it's still going to be right. It's always going to infer whatever this is. Because those generics are in place. So now the advantage of having this signature is now that when people consume this in a project that's a full stack TypeScript project, so this is only relevant for people who are doing full stack TypeScript, is that in their kind of React pages. So I've got a page here. Sorry. I'll touch on this utility in a second. They can. Where should I start with this? So I'll touch on this first. So let's really unwind this. So I've got something here in my TS config that I haven't told people about quite yet. So that is, I've got a path alias, which is basically like shorthand. And so anything that is /API/ will reference that same path within the pages API directory. And so that's what allows...
This is so that you can easily sort of use in the front end these like API types that in the file system they happen to be under pages API and so on, but you just want to keep it concise so that it's clear that this is actually a backend sort of type, a database type that you're importing.
Yeah, spot on. And then the import keyword here, for those who aren't familiar with TypeScript, is it will actually give you the type of that module. So if we look at that type in practice, we do something like this, API posts, and we put type off in front of it. And we look at the type, it's aliased sadly, but if we go something like return type, and we go default, let's try that. So that's the default export of the module, and we'll get our signature there.
Right.
Except at the very...
That's the function signature.
Exactly, yeah. So that's the default export of that file. That's the function signature. And at the very end there, unfortunately, it's ellipses out a little bit, but there's the promise there instead of void. And that's what we're going to try and tap into. So now we're going to try pull that promise out and use it as the return type. So for that... I've created a little utility here called API. Again, I've really tried to strip it back. You will want to have one similar to this, but under the hood you can do whatever you want. You can use Axios, you can parse it to JSON or check the content type if it's text, return text, do your error handling here, send toasters, whatever you want to do. I've just really stripped it back just for this example. So again, another generic. again, it's just variables for types, and we're saying that the variable here should be something that looks like a module that has a default export. And the default export should always be something that takes a request, response, body, query, and returns something. You can have any here, never's just a better alternative. And then it takes a URL, standard like Axios style, I guess, a little bit, method, headers, body, and we'll loop back on this in a second, but then it just runs fetch and returns the JSON. And the only thing that it's really doing different than fetch is that it's just doing the types for you, right? So it takes this T, this type variable, and in the return type of API, it's returning a promise of the API response of T. API response is another utility, takes the same signature. It just gets the return type of that function, because that's the function signature we saw earlier that returns the promise ellipses. Yep, and then it just unwraps that promise. And there's a few reasons you'll want to do that, but I'll maybe talk about them another time. But
that is unwrapping the promise, you mean?
Yes, correct. Yep. So now, because the return type is promise users,
that's because you wrap it again. So API response unwraps the promise, and then it seems like the return type is a promise of whatever's been unwrapped.
Yeah. So as the return type is a promise. Yes. Yeah. Correct. Yeah. Yeah. And this is just because there's a weird little edge case here where you might have a function that for some reason doesn't return a promise, but this utility should always return a promise. Fetch always returns a promise, so I can't just consume the return type blindly. Yeah, I unfortunately I'll need to unwrap it if it's a promise and then wrap it again just in case. So even if you have something like this,
what will unwrap promise do if it's not a promise? If the return type, will it raise a type error?
Yeah, so this one will just return never. So yeah, probably a bad implementation, but yeah, it should actually just what should I do in this scenario? Just pull out. Just return T. It should just return T here. Yeah, so you can handle it however you want. Now that we have all those types in place, so again, return type here, for those who aren't familiar, is a TypeScript utility that'll give you the return type of a function. And again, this is just our default export from our module, so then this whole expression would evaluate to promise of users. Then we unwrap the promise, wrap it in a promise again, and just like that, we've got the type of the posts, or undefined.
Wow.
So that is this, that's what this provides. This utility that we've exported, and then this API is the fetch equivalent, and so you can also just pass that same signature there and the endpoint, and then set data, and then it's all type safe, so you can map over that data, and you get full auto completion here with ID and all your stuff. And what's really cool is if someone goes in and changes that API in a way that breaks that contract that you're relying on, instantly TypeScript will warn you, right? And it'll be like, we removed the name field and people are relying on name.
Can we try that, actually?
Yeah, sure. So
can we take one of the API routes and say change it from post to user find many, or
So we'll go something like this, hello world. And so now back in our front end code, just instantly it'll just start saying you can't map over this, right? This is it's gone to a node. Why have I done that? Oh, because it needs to return a promise. That's fine.
Yeah.
We'll touch on that later, and then get rid of these. Okay, and there we go, that's better. So now, there we go. So now it's correctly inferring it, and now it's saying you can't map over that because it's not an array, and so then post is, implicit any, but, so these are failing.
One more question. In the use effect, why is it starting the function, the arrow function there with void?
That's because useEffect can't let you return a promise. So if you do that, useEffect will complain. So you can just do this and not return.
Ah, I see.
Yeah, but the return type useEffect expects is the
cleanup function.
Exactly. Yeah, the cleanup function. So you can get around that just by returning void, because useEffect and void just makes this expression return undefined, and then you can keep it all in one line. It's like
okay, so it still makes the API call, but then it's like a nice trick to keep it concise.
Yeah, exactly. It's just a nice trick to allow that to happen, and you don't have to return the cleanup function, and don't have to break it onto a new line. And then you can, make this beautiful and create like a React query style hook, or use SWOR style hook, and just make a use API hook that does this use effect and this use state for you. basically. So you can have like data and go use API posts. And I'll touch on one last thing that people might think that they can do but can't as well. So unfortunately, although this looks like duplication here, I'll show people this utility as well. So that's still the same now, that's still hello string. Except it's just doing that use effect and that use state for us now. And it will also give us other information, like if it's loading.
Use an API is basically a hook that combines a bunch of hooks for you, right?
Yeah, so use API is just a hook that just runs API and a use effect pretty much for you and sets data, but it also gives you some extra information like whether that API call
so it
is
gives you
loading.
the loading state. So it's kind of like React query, but fully typed for interacting with your API routes.
Yeah, spot on. Yeah, exactly, spot on. And yeah, unfortunately, with the way TypeScript is currently, this looks like duplication. But unfortunately, TypeScript doesn't allow you to use generics with the import utility. Otherwise, if they did, you could actually just reduce the signature down to this, where this is pulled into that import utility and that happens for you. But unfortunately, the import utility just can't take generics. So till TypeScript kind of fixes that.
So basically the duplication, it's not really though duplication. In one, you're defining the route that you're going to call in your API call, and the other, you're actually defining where you want to get that type from. So in your case, you've obviously kept that consistent, and theoretically, if you could use generics in import, is it?
Yeah.
Then you would be able to just boil that down to just use API, and you pass the path, and then TypeScript will figure out, oh, I'm actually using this to both get the type and at runtime also to actually call that specific string path for the API.
Yeah, spot on. And so then we started implementing this everywhere and had amazing success with it. I hope people can see why. And so then we started improving it, and we added like body type safety. So you can do like, I'm hoping this will work, but we'll touch on how this works in a second. So fortunately, it resolves to, it just allows anything unless you type it. We can go above and beyond for that, but for now the default is there. We'll just allow anything if you don't type it.
This is basically the request body, right?
Yes, spot on. Yeah, so
this is what the client side would send to the API route.
Yeah, correct. Yeah, and so if we add this little annotation here now, so we're saying body is something that takes an API of number, then back in our use API utility call here, it'll allow this, but hopefully not that. Yeah. So it'll say string is not assignable to number. So now you have type safe on the actual contracts to the back end as well. And the way that works is that because we have this extra parameter here for body, so instead of accessing rec.body, which isn't easily typable, we're adding that another parameter for that and calling it body, which we can add a type annotation to. We can tap into that type annotation back in a utility, and we can just say whatever that function is, just get the type of its third parameter. So that this is just TypeScript syntax. This parameter is a TypeScript utility, and it just says that if this thing is a function, get the third parameter and get the type from that. And so this will be ID of number for us, and we just add that type here.
And T default is basically the default export of the module,
correct,
which you showed us before.
Yeah, T default is this guy's default export, and that's another thing as well, is that developers can click into this, which I find really useful as well. So when they want to see an API definition, they can just like click into go to definition. They can actually see the API. But yeah, spot on. So the that is. Oh, say it again. What you said? It's the.
Yeah, basically, it's just I was pointing out in the utility type that you're taking the default export of that.
Yeah. So that is this. Sorry. Yes. So that it's the type of this default export, and import by itself just gives you the type of the whole module, which could contain other exports like named exports. So yeah, export default just takes the type of this. And then we also have type safety on the query as well, the same way. So you can also type the query of your query parameters using the same method here, and give it like query of like skip string, and same resolution happens. And then that gives you the whole type safety both up and down, and it prevents, like I mentioned before, against people refactoring APIs and all this stuff. And what's even cooler is with Prisma, you don't even have to have like an interface like iResponse or something where you're typing this yourself, Prisma will just give you the types right for you. So you just go return rec.client.post.findMany, and it all just flows through. There's no need for interfaces. This is just basically JavaScript. There's no TypeScript here other than this tiny annotation. So
I guess that brings us to the benefits of this approach. It sounds like one of the main benefits of this approach is that you're really just heavily leaning in on the TypeScript compiler. You have to define some sort of utility types up front, but from that moment, after you've sort of defined it and set up the structure, you can really sort of get developing without having to add new types. Really, you just rely on what's there, and some, you can do, as you mentioned, right? You get the return types automatically in your client-side fetching hooks, and you also can very easily type, as you showed, the body, sort of the request parameters that are coming into the endpoint, and you can have them sort of typed also in the front end so that, if you're passing in, say, a request parameter to an endpoint that expects an IDF number and you pass in, I don't know, say, a UUID string, then you will get a type error immediately. And that doesn't really require you to do much except for annotate this body.
Correct. Yeah. And yes, it's super easy to use and super easy for juniors to understand as well, which is another key thing that we kind of promote within Qrious, is that you should always be writing code that even a junior could read and understand. And I feel like juniors might not understand like this utility and what it's doing, but if they come read this, they can definitely understand like exactly what's going on here. Like, it's just the standard Express style that they're used to. There's a lot of magic going on under the hood, but they're just reading this simple signature.
Yeah, I think we like to call that the pit of success. And this was something that I think was really a strong design constraint that was always at play in the sort of the Prisma client API design and how we sort of think about developer experience. It's really, like trying to see how can we make this workflow work in a way that will allow developers with any experience to succeed without giving sort of too much variability and, too many invariants that you have to account for.
Yeah, pit of success is the perfect analogy for that. And I think Mark Seaman has a talk on the pit of success with functional programming as well, which is a really good talk to watch for those who want to watch it. But I'll
be sure to add the link in the description.
Yeah, it's really, it's exact. The pit of success analogy is perfect because it's really hard for developers to actually roll the ball out of that pit because it's so much things are in place to stop that happening.
And so, interestingly, one of the things that evoked this conversation was a different interview with another great member of our community who built TRPC. Yeah. How do you think this approach compares to TRPC? And sort of, if you were starting out now in a project, how would you sort of evaluate the two? And what are the different trade-offs? Because obviously there are no ideal solutions. There's sometimes better solutions, but really, we're always in engineering dealing with a game of trade-offs.
Yeah, exactly. So there are a lot of strong things that runtime types can provide you that might be beneficial to your team. And like I said before, if your team's running a lot of external APIs, then that's going to be a very attractive value proposition for your team. Because then you won't have this double declaration problem, as it's called. Like, you're going to be validating and getting the type from the same thing. So your validation schema and your type, they're completely the same thing. And so there is immense value in that if you're writing a lot of external APIs. So I'd say the point of difference...
You're referring to TRPC in this case, right?
Yeah, so I believe TRPC does have runtime types. That's their approach to end-to-end type safety. And then I think they were using the type of operator to pull the interface from that. Yeah. But I would say if you're writing predominantly internal APIs, this is probably going to be a little bit more easier for you, or at least you'll be writing less code. But you definitely need to think about the use case you guys have within your project or making a decision.
Because basically the approach that you showed us is really nifty for getting these types all the way, from the database to through the serverless functions to the front end, but it doesn't cover things like runtime validation. And we spoke about, sort of the differences between type safety and runtime validation. And so I guess from what I understand from what you're saying is that TRPC essentially starts off, sort of the main building block is that you define runtime validations, and then it sort of derives the types from that and sort of gives you the type safety with the addition of also validation.
Yeah, absolutely correct. Yeah, absolutely correct.
Great. And so as we sort of come to the end of this talk, I'm curious to hear, like, what does rapid development mean to you? You spoke a lot about, productivity, ways to sort of ensure productivity across your team and make it easy for, say, front-end devs to really get into the back end. I'm curious, how do the tools that you choose help you achieve that? And what are some of the other tools that perhaps you haven't mentioned so far that you think are worth mentioning in the context of, like, rapid development, productivity, without sort of compromises on confidence?
Yeah, absolutely. So rapid development's a really good one because I feel like modern web application development or modern software development really is moving towards rapid development, like as an ideology. And I feel like things like agile, is all about gaining your team greater agility to rapidly deliver. Right? It promotes continuous iteration or endless iteration as well. So, what does it mean to me? I think it means that it's a philosophy your team should try and live by, for sure. And there's all sorts of things that you mentioned tooling just then, but there's all sorts of things that you can do to kind of help facilitate that. I mentioned trunk-based development before as an alternative to Git Flow. I believe that trunk-based development allows you to have rapid development easier, but it isn't always possible to have trunk-based development because if you're in like a highly regulated environment like banking or fintech or something, you are going to have a hard time convincing your product owner to just push to master continuously without going through proper regulation, compliance stuff. And also in terms of rapid development, that's like the, I guess, non-functional side of things. Then you've got the whole tooling and team side of things where you definitely don't want to be using any tools that, or any kind of ways of working that create large feedback loops. This is kind of like an anti-pattern that you should probably watch out from your team. If there's like a build pipeline that takes like 30 minutes to run, so your developer just sits there for 30 minutes waiting for this build pipeline to finish, or what are some other signs of this? You guys are spending 8 hours a week in internal meetings, all this other non-functional stuff. Get rid of all that. And then on the tooling front, make sure you're using tools that have a strong focus on developer experience, I think, definitely. And using tools that are built to stand the test of time. So look at who's maintaining the tool. They hopefully are a big company like Prisma is, and so you can put your trust in them that they're going to look after this tool in the long term. You won't have to refactor your whole code base. You can trust them to do a good job, and you can just focus on developing and therefore go fast.
Thank you. And what feature in Prisma do you most look forward to?
PostgreSQL types. Can I send that feature request through now? Geometry types would be great. I think we're using JSON at the moment. I can't remember, or TypeRM for that. I can't remember. But yeah, PostgreSQL types would go a long way. But also on the Prisma front, I saw your talk on the Prisma data proxy, and we're also excited about that. Prisma Data Studio is an awesome one that we haven't had a chance to play around with because we don't use Hasura on projects. We normally just use Hasura's UI for a lot of things like creating migrations and stuff like that. So we don't use Prisma Data Studio, but we probably will start at some point.
Before we get into our last fireside question, I'd like to also ask about what is the role that Prisma Migrate has in your workflows? Do you rely on it heavily?
Sadly, not at all yet. Sadly, not at all. But on the next Greenfield project, it'll be Prisma Migrate from day one. Yeah.
Great. And so one last question. What technology are you most excited about in the coming year?
I saw, I think it's your talk with PlanetScale, or Vercel's talk with PlanetScale, and really got me excited about that. So definitely excited about PlanetScale. Excited about Snowflake, although I'm not really a database guy. Excited about the improvements that are coming to Lambda. So I think I read somewhere that Lambda usage is up 300% over the last 2 years or something. Some crazy statistic where the Lambda community is just basically exploding. So I'm really excited to see what new stuff comes from that, because I think it's going to provoke these kind of cloud providers to invest more in serverless. And I think we're starting to see that unfold now, where you're getting these serverless databases come out. You're getting AWS investing in Amplify and DynamoDB and all sort of stuff. So yeah, excited in everything serverless is probably the answer as well.
Yeah, it seems like the future is really in serverless. And while serverless compute has really been around for quite a long time, I think that the sort of side of data, serverless data and really serverless databases is really starting to catch up. And we're at this really exciting moment. Also use this opportunity to, if this is streamed before the Next.js Conf, I highly recommend you check out the Next.js Conf talk that I gave, where I really discuss this topic of databases and serverless. It's an exciting time, and I think PlanetScale is one of those examples. There's also CockroachDB, and they're doing some fantastic work. And really, I think the Prisma data platform is going to play an important role in sort of like making your sort of developer experience, going from prototype to proper production scale is going to make it much easier. And we're already sort of seeing some of the feedback that we've been getting from the early access users. I think as of yesterday, as part of the 3.30 release, it's now in early access, so it's available for trying out. So if you are using databases with Prisma in serverless, I highly recommend you check it out. It can really eliminate a lot of the connection management problems, which are, serverless functions are so prone to, especially when working with traditional databases.
Yeah, I think that I did watch your talk on the Prisma Data Proxy. I thought it was really good for people who are running serverless environments to hear. So yeah, I was really impressed by the work that you guys have done in there. And I think one of the things that people don't understand as well, that was kind of missed in that, is that sometimes it isn't about the number of connections your database can support, because the RDS tiers have like thousands of connections available, 1,500. But just because you have that many connections doesn't mean you should be consuming them all, because it has all sorts of other implications on Postgres and other databases, like taking up huge amounts of RAM and all sorts of other things. And so, I was amazed by the work you guys have done with that, because that's actually a tangible problem we've actually had in projects, is we've actually capped out the number of database connections often. I can, off the top of my head, I can think of at least 4 to 5 times people have written code that has capped the number of database connections. So, yeah.
Yeah, absolutely. And I think there's also exciting stuff happening on the compute side of serverless with, things like Cloudflare workers and, Fastly's Edge Cloud, Edge serverless platform. It's going to be a lot of really fun stuff that I think ultimately will make, people's lives better in terms of, being able to really build and create value for, their users and their community without having to worry about infrastructure and scaling and so on, really just being able to focus on what matters, which is, the problems that we're all solving.
Yeah, absolutely. And that probably fits into your web development thing as well, because the more work you can offload off your developers and just let them focus on developing, the faster they're going to go. And I think serverless fits into that quite well as well, because they don't have to worry about patching servers and availability and all these other constraints and compute.
Shanon, this has been really fun. Thank you so much for joining all the way from New Zealand. I know it's pretty late on your end. Before we leave, where can people find you online, if at all?
Yeah.
And is there anything else that you would like to share before you wrap up?
Yeah, so I have a very thin online presence. So I'm at Shan Shrew on Twitter, ShanShrew. And other than that, feel free to reach out to me on LinkedIn. You'll probably be able to hunt me down. Yeah.
And you've given a talk at TypeScript TSConf, was it?
Yeah, TSConf 2020.
Was it 2021?
Yeah, 2021. Yeah, so I did a workshop on one specific use case for the TypeScript compiler. So I've done quite a lot of work over the years with the actual TypeScript compiler, and not as a type checker, like for actual production use cases. So my talk's on one of these use cases that we found.
Is that talk available? If so, I'll be sure to add it to the description.
Yeah, I don't think it's quite available yet. I do know they'll be posting them to YouTube at some point, but unfortunately, I think the only way you can watch it at the moment is if you bought a ticket to TypeScript Conf. But at some point, it should be up on YouTube because the 2021s are there. So, yeah, if they're not up on YouTube, right, feel free to flick an email to SitePen and complain, and tell them to post them up.
Sure thing. Shanon, it's been great. Thank you so much for joining today for Prisma Interviews, and we hope to have you here soon in the future to tell us more tales about your adventures with TypeScript, serverless, and databases.
Yeah, awesome. Lovely to meet you, Daniel, and thanks for your time.
Thank you.